Welcome friends, today I am going to explain about boron hydrides. In my previous two videos I have explained about lithium hydride and beryllium hydride, and today is boron hydride. So before going to details, I want to mention that boron is a 2p element with an electronic configuration of 1s2, 2s2 and 2p1. This S is not the outermost valence shell, that's why 1s will not participate in bond formation. Only this 2s and this 2p will participate in bond formation. And before the participation of bond formation in case of BH3, they undergo hybridization to form 3 sp2 hybridized orbital and one vacant pz orbital, and this one orbital react with one hydrogen and filled up and form this BH3 molecule, and this we will consider as a pz orbital which is remaining vacant. So BH3 molecule is actually like this with the vacant p orbital. So okay, so BH3 actually a 6 electron species, or it is having sextet. We will explain. Due to this electron deficiency, it will have some unique bonding also. So friends, I am Tanmoy. Right now I am doing PhD at Indian Institute of Science, Education and Research, and I am doing PhD in chemistry. So today we will discuss about this BH3 molecule. So before going to anything further, first we will explain about the preparation of BH3, how this molecule is prepared. This BH3 is prepared from boron halide. As for example, boron trifluoride reacts with lithium hydride and results in the formation of BH3. Actually it produces a dimer of BH3 that is equivalent to B2H6 plus lithium fluoride. In my previous video I have mentioned that lithium hydride is a unique molecule. It's a lowest molecular weight ionic compound. Its molecular weight is 8 and it is ionic in nature. Similarly, BF3, BCl3 can also result in the formation of B2H6 by the reaction with lithium aluminium hydride. And another product is lithium aluminium chloride. Here you can see it is unhybridized hydride, that is its electron is in 2s, but this is hybridized, it is in electron is in sp3 hybridized orbital. So one different type of question could be given to you. For example, this boron halide BF3 plus sodium borohydride, what will be the product? If you don't know this answer but you know this two information, then you can conclude what will be the product. For example, a hydride reagent react with BF3 to produce B2H6 and it is in unhybridized, that is the electron pair in s orbital, and here one sp3 hybridized orbital reacting with this BCl3 resulting in the formation of B2H6, and this is more nucleophilic compared to this hydride, and here sodium borohydride, that hydride is also in sp3 hybridized, so it will also result in the formation of B2H6. So what is remaining? This sodium and fluorine. So product will be sodium fluoride. Okay, so right now we are going to discuss about the bonding of this B2H6. Please keep it in mind that the bonding of B2H6 is very important. As I mentioned in my previous video that this B2H6 molecule have a very famous 3-center 2-electron bond, and in my previous video I have also compared this 3C2E bond with 3C4E bond of AlCl3 dimer. So let's draw the B2H6 first. This is boron, this is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen, and here two bridge hydride. These hydrides are bridge between these two boron atoms. It is expected that this bridge hydride will be weaker compared to this. So let's see. Actually, here the one bond pair, that is 2 electron, is shared by these three centers, center 1, center 2 and center 3, and it should be drawn in a different way. For example, 1, 1. Here is one pair of electron and here is one pair of electron, and this electron pair is shared by 3 atoms. When this electron pair is shared over 3 atoms, then it is expected that the probability of finding this electron pair in this bond region between this BH bond will be lesser compared to this 2 center 2 electron bond of this BH. This is 2C2E, because that bond pair is confined between this boron and hydrogen, the center 1 and center 2. So it is expected that this bond will be stronger compared to this, and which is further verified by some experimental data. For example, the bond length of this bond is around 119 ppm, although this bond length is around 131 ppm. And the similar thing is also observed in case of higher stretching frequency, where the stretching frequency is lesser in case of this bond, which is 2100 centimeter inverse, whereas this bond have a stretching frequency of 2500. This is also indicate that the strength of this bond is more compared to this 3 center 2 electron bond. So where there is weakness, there is an opportunity for chemist. For example, this is the weak bond, so it is easier to break, and that will result in some exceptional property which we will discuss after some time. So here now we are going to explain some other properties of this B2H6 molecule. But for example, its reaction with different molecules. We can say boron hydrogen material like hydroborane, similar to hydrocarbon. If we consider in that way, hydrocarbons are highly flammable, and right now they are supplying the major energy demand of this globe. So it is expected that this BH3 dimer will show exceptional reactivity with oxygen, and actually it is observed. This B2H6 reacts with oxygen violently to produce B2O3 and water. This water is the most stable oxyhydride molecule, and this boron oxygen has a unique stability because boron is a sextate in nature. So if it forms a bond with oxygen, then eventually it decreases its electron deficiency, because we know that boron has a vacant p orbital and oxygen have electron filled p orbital. So this can donate its electron to the boron, and which will eventually satisfy the electron deficiency of this boron atom, which is 6 electron. So in this way boron will get stability. That's why boron has a higher affinity of oxygen. So in my last video I have explained about the property of water and its reactivity towards other reagents, because water contains the delta positive hydrogen and this boron contains delta negative hydrogen. So this water will react with this B2H6 and ultimately result into the formation of boric acid and hydrogen gas. So when we are discussing the reactivity with water, we should also discuss some organic solvent, and the closest counterpart of water in organic molecule is methanol, because if we replace one hydrogen with this methyl group, then ultimately this reagent is produced. And similarly, water, it also reacts with B2H6, resulting into the formation of trimethoxyborate along with hydrogen gas. Okay, so right now we are going to explain or see another unique reaction which will eventually produce one unique reagent, that is borohydride. And here the reactant is lithium hydride. This lithium hydride reacts with B2H6 in diethyl ether to produce that lithium borohydride. I will make a dedicated video on this borohydride and its reactivity towards organic molecule later on. So this is the property of this B2H6. So let's discuss some unique property of this B2H6 and the role or importance of weak boron hydrogen bond. As from the previous drawing of the structure of B2H6, we have observed that this B2H6 contain 4 2-center 2-electron bond and 2 2-center 3-center 2-electron bond, and these bonds are weak, so it could be broken easily to form the BH3 molecule. But this BH3 is a 6-electron species, and in this molecule they form this 3-center 2-electron bond to reduce that electron deficiency, and eventually each this boron will fill up its octet because of this 3-center 2e bond. But here it is 6-electron species with a vacant p orbital. So we know that every reaction occurs in order to achieve stability. So here reaction is also occurring because of achieving the stability. Consequently, it will be possible if any reagent is there which can donate its electron to this boron's p orbital and reduce its electron deficiency, then only this breakage will happen. And actually this happens in presence of electron donor like oxygen, and the reagent which is used to break this and produce a stable BH3 adduct is tetrahydrofuran. This tetrahydrofuran looks like this, and this contains 2 lone pair of oxygen, and this coordinates to the BH3, and in this way BH3 satisfied its octet and stabilized. But there is a problem, because oxygen is electronegative, so it don't like to give electron. Actually it likes to take electron or keep the electron closer to it, so it will not donate that much to the boron, which will ultimately stabilize the boron. So we can find some alternate by searching on its homologous series, and that is dimethyl sulfide, or in short DMS. How this material look like? This is methyl, this is sulfur, and this is methyl. Since sulfur is the homologous of oxygen, it should have 2 lone pairs of electron, and this could be donated to BH3. And actually this reagent is very stable compared to this BH3, such that it could be used for a very important well-known reaction of this BH3, that is hydroboration, which eventually result into the formation of alcohol. And the reaction is first, a trialkyl borane is formed, which reacts with hydrogen peroxide to produce alcohol. So in this way, this alkene could be converted into alcohol, and this is a very famous reaction, and I will make a dedicated video on this reaction later on. So this is the reactivity of this oxygen BH3 or sulfur BH3 material. But we know that nitrogen also has its lone pair, so it can donate in like in ammonia molecule, nitrogen is attached to 3 hydrogen and it has one lone pair which could be donated, and in fact in reality this thing happens. This ammonia react with B2H6 and prepare different material. For example, this B2H6 reacts with ammonia at low temperature. In presence of excess ammonia, low temperature, it forms this NH3BH3 adduct, and upon heating these, it results into the formation of boron, nitride and hydrogen gas. This is a unique reaction because here from adduct hydrogen is produced, and hydrogen is one of the cleanest fuel. So this material is considered as the hydrogen carrier. Okay. In presence of stoichiometric ammonia, that is 1 boron is to 1 ammonia, and at high temperature, this results into the formation of borazine, a cyclic compound which contains no carbon, but its structure is similar like benzene. That's why this is called inorganic benzene, and its formula is N3H6P3. So we will see the structure of borazine. So to remember the process of drawing borazine, you people may follow this technique. The technique is, first draw a 6-membered ring and arbitrarily place one boron or nitrogen, and after this alternate boron nitrogen you put. Okay, and after that put 6 hydrogen attached to 6 atom of 3 nitrogen and 3 boron. And another thing, nitrogen has a lone pair and boron has a vacant orbital, so this lone pair could be donated to the boron, and in this way the material will be stabilized and its structure will look like benzene. Actually, if we draw the structure of benzene, it looks like that all carbon atoms are attached with hydrogen and they have 3 double bonds. And you can see after this donation, after this electron donation, this material will also look like benzene. Nitrogen, boron, in this it will look like this. So we have observed this borazine, and one statement is made for borazine which could be very important, and I can make one MCQ question from it. What is the statement? This borazine is isostructural and be isoelectronic like benzene. So the question may be, borazine is isostructural like benzene, 1 in point 1, point 2, isoelectronic like benzene, point 2, point 3, both A and B, and 4, none of these above. So one simple MCQ could be constructed from this. So if you know this exact thing that borazine is isostructural as well as isoelectronic, then you can answer this question very easily. So this is the borazine. So this is actually the end of the video, but before going I will give one question for you. I expect that you should try, and the answer of this question I will explain in my next video. So the question is, let's first draw benzene and draw borazine. I am drawing in this way, but you prefer to follow that technique. First draw the hexagon, then alternately put boron, nitrogen atoms. And the question is, hydrogen chloride is reacted with both benzene and borazine. What will be the product in both reaction and why? That means you have to explain your observation for this reaction. So you should try this question. I will give the answer in my next video. So thank you everyone to watch my video. I am new in YouTube. If you like my videos, please subscribe my channel Chemistry, the Mystery of Molecules, and I will update many videos later on. And so ultimately I again thank you everyone.